Hello, hi friends, welcome. This video is the continuation of the Cloud Native Ninja series. Today we are going to see how to containerize React application or a front-end application. So far in this video or in this series, we have seen how to use polyglot programming to design our microservices for the backend. We built TechTalks producer and TechTalk consumer, which helps us to decouple the producer and consumer logic. And we are also using a distributed application runtime called Dapper, which helps us to interface with our messaging infrastructure, which is built on top of RabbitMQ. So the focus of this video is about containerizing the front-end application, which is built using React as the technology. My name is Nilesh, and let's get started. Before we look at anything else, let me switch over to the Visual Studio Code and quickly walk you through what are the different things we have in the front end. So I have a very simple index.html page or index.tsx, which is the extension for TypeScript. We are using TypeScript as the programming language for this. Now to get started, I assume that you know how to create the React application or how to get started with React application. If you don't know, this is how you can start to generate a template with React. We can use npx and use this create React app, whatever is the name of the application. In this case, I am giving TechTalks UI or TechTalks-UI as the name of the application. And the template that I'm going to use is the TypeScript based template. So I want to use TypeScript as my programming language. Once I do this, if you look at the files that are generated in this, I ran this command in the src folder. So we have the TechTalks UI as the top level directory or the folder. And then we have this public src node modules, and it generates this app.css, it generates index.css, index.tsx, logo, and all these default files which come as part of the template, which is used for generating the user interface for the React application. Now I've added some things which are required for my own user interface or the elements that I need to be shown as part of my UI. If you remember from the earlier videos, or if you go back and try to understand what the application is doing, it's producing a certain number of messages, and on the consumer side, these messages are consumed in a batch. So what I'm trying to do here using this user interface is to provide an option for the user of this application to go and generate a fixed number of messages. So we start with a function which will handle that selection in the change of whatever is the value selected. And then when we hit the submit button, we will have a user interface which shows the submit button. On click of the submit button, it will call a API. In this case, I have deployed the API to one of the service in Azure Kubernetes Service or AKS. So I'm connecting to that API or endpoint, and we pass the selected value, whatever is the number. And then we set the response. If we get the response code as 200, which means that the API was successful in generating whatever the number of messages we requested, then we will say it is a success. And if we get any other response code, then we will say that something went wrong, and we will display the failure message. On the form side, what we show is a message saying select the number of TechTalks to generate, and we give the options from 50 to 500, 5,000, 10,000 and 50,000. These are the different options. Once the user selects one of these options and hit the submit, it is going to perform those actions that we saw earlier in the function. So that is a very, very simple user interface. Once we have this code, we need a way to containerize this. And for that, we are going to use this Docker file, which will help us to containerize the React application. We start with using the base image, which is based on node 19. And we are also going to use the Alpine based base image, which gives us a very small footprint. Once we have the base image, we create an app folder or a working directory named app. Inside that, we copy the package.json file into that app directory, and then we run the npm install command. So this is exactly similar command that we would run on our local machine to build the application. and then we run the npm build. So npm install will install all the dependencies that we are referencing in our application, and the npm run command will build the application. Once we have built the application, we don't need the complete Node.js base image. Here we are switching the base image to a Alpine based Nginx image, and we copy the output from that build folder into the HTML directory under user share Nginx folder, and then we expose the port 80. Finally, we also run the command, which is nginx-g, and we set the daemon as off. So with this, we can go onto the command line or terminal, and we can generate the Docker file for this. So we use the docker build command, or we can generate the container image for this. So for generating the container image, we are going to use the docker build command. We use docker build. I am inside my main folder here, or main branch, and under that I am inside the TechTalks UI folder. So before I run this command, let's see, list the contents of the file. We should be running this command relative to the Docker file, whichever location that Docker file is residing. So I have the Docker file for this React application in the base directory where the TechTalks UI folder resides. So let's go and run the docker build command here, which will enable us to build the container image. So we are running this command docker build, and since we are using the conventional Docker file as the file name, we don't have to pass the -f flag here. We want to tag this image as Nilesh Gule /TechTalks UI and with the tag as React, and we are passing the context as the current folder for this build command. Once we generate the image or generate the file from the container, we can see that it had the cache data from my earlier docker build command. It's going to run all these commands that we specified in our Docker file, like creating the app folder, copying the package.json file, then running the npm install, copy the output, and then run this npm run command. And finally, we also copy the output from that build directory into the Nginx folder. So now if I run the docker images command, earlier before I ran this, there were only 3 images that I had, one for Redis, one for the Zipkin, and one for Dapper, which is required for my microservices, which I developed using the polyglot programming. Now if I run docker images here to list down all the images that I have on my local machine, we can see that there is an image generated just about 35 minutes ago. This should have been just now. Let's go and do one thing. We prune this to make sure that the image that we generate is the latest one. When I run the docker system prune command and I give all and -force as the flag for that, it will delete all the images which are not currently in use, and we are reclaiming about 300 MB of space here. Now if I run docker images command, I should see only the images which are related to Dapper. The 3 images, Redis, Zipkin, and Dapper. Let's go and run this command once again to build our container for the TechTalks UI application. Since I'm running it again, when I generate the images or when I list the images again here, we should be able to see that it was generated few seconds ago and not minutes. So we can see that it is pulling the base layers from the node image, Alpine based node 19 image, and we switch over to the terminal and let's list the docker images command once again to see what are the images. So we still have those 3 base images or 3 initial images that we had, and this command is running for about 45 seconds. We should see our application built and containerized in next maybe 4 to 5 seconds. That took quite a bit of time, more than what I had initially expected. but that is what would happen when we run the first time. This happened because we cleared the cache for Docker and it had to rebuild the whole cache. This would happen even without Docker if we were building the application for the first time and Node had to download all those Node modules, and if they did not exist on our system, it would take some time to download and build the application. So this is natural. There is nothing new in this. Now let's go and run the docker images command again to see that we have this new Nilesh Gule Tech Talks UI with a tag as React, and we can see that now it has been rebuilt just 46 seconds ago, and the size of that image is just 12.1 MB. Just to say that what I said just now about rebuilding the cache, let me try and rerun the docker build command again to see if it reduces any time, because we have the cache already built. My expectation is that because the cache is already available in the local Docker daemon, it should be able to build the application faster. So here we can see that it's transferring the context. It's trying to load the metadata, and it will know that all those binaries or all the dependencies that we pulled, they already exist. So that is why it is able to generate. There is no change in the code. So Docker has this internal mechanism to identify if there is any change. So it's able to build this image in less than 6 or 7 seconds on the second attempt. So that way we know that we can build the image or the container using our docker build command. How do we test this? In order to test, again, I will switch over to the Visual Studio Code, and let me copy the command for running the image. I can use the docker run command to test the application locally. So let's copy that command and switch over back to the terminal. Let's clear all of this and let's run docker run, and we create an instance of this container that we created just now. We will do the port mapping. The internal port that is exposed on the container image is 80, and we are going to map it to 3000 port on our local machine, and the image that we are going to use is this Tech Talks UI and React application, or with a React tag. The container is started, and we can switch over to the browser, and if we hit the localhost 3000, we should be able to see the application running. So we can see the UI has this select the number of Tech Talks to generate. Let's go with 500 for example, and we submit, and we can see the success message coming from the response or generation of this 500 messages. So this UI is very simple and very minimal. The purpose of this application is not to show how to build a React application. If you are interested, you can enhance the UI of this. I'll be happy to take pull request in order to improve the user interface for the application. But let me switch back to the slides and see what did we do so far in this. So we started with a multi-stage Docker file, which allowed us to create separation in the build and the deploy stages. For building the application, we used Node 19 based image with the Alpine as the base OS on which this Node 19 is running. Then we copied our package.json into that. We ran the npm install to install the dependencies, and then we used the npm run command. These are exactly the same commands we would run locally on our development workstation without even having Docker. So the process is similar irrespective of what programming language we use. We follow a similar steps when we use the multi-stage Docker files. Once the Docker file is built, or once the output of the application is ready, we use a different image here as a base image for the target deployment environment. And in our case, we are using Nginx, again Alpine based slim image, and we copy the build output from the previous stage, which is named as build here, from the location app build. That is where we copied the output of our application, and we copy that into the HTML folder, and then we expose it on port 80, and we also have a startup command. So in summary, we built a React application using the npm commands, npm build and npm run, and we also used different base images. We used Alpine based base images to have a very small size. They gave us a very minimum set of Unix utilities in those images, which makes the size of the images very small, the base image. And we also used a node image as the base image. In the multi-stage Docker build, we separated the build using the node base image for building, and for running stage we used the Nginx. And we also published this. So let me show you how we can publish this to the DocekrHub. So I can use the docker push command here and give the name of the image which I want to push to DocekrHub. DocekrHub is the public container registry where I'm going to publish my image. The name of the image is Nilesh Gule, and or the repository or the workspace where I'm going to publish this is Nilesh Gule. And then TechTalks UI is the name of the image. The tag is React. Once this is pushed, I can go to DocekrHub and I can find this image there. So with that, we conclude the part where we are building the application. These are all the resources related to this Cloud Native Ninja series. This is the 8th part of the series. All the slides related to this session as well as the previous sessions, the videos which are related to this Cloud Native Ninja are available on SlideShare and Speaker Deck. We are at a very critical juncture now where we have built application using polyglot programming languages. We looked at how to build producer and consumer using .NET, Java and Go programming languages. In the future parts of this series, we will see how to deploy them to different target environments like a local Kubernetes instance running inside Docker Desktop. We will also deploy it to OpenShift. We will also deploy it to a fully managed Kubernetes. And in later part of the series, we'll also see how to use serverless using Azure Container instances as well as Azure Container apps as the different options for deploying these container images. So I hope you found this useful. In case you like this video, please hit the like button, subscribe to my channel, and I look forward to sharing more of these kind of content with you. Thanks for watching this once again. Until next time, code with passion and strive for excellence.